Hello everybody, my name is Margot Bridgers and this is a presentation for my charge tapes lab. This is lab number 1 for Physics 2 and I'm in group 9. So let's go ahead and talk about the introduction and the background of this lab. I will be having a video that is playing while I discuss the lab, which is the video is me conducting the lab. But regardless, let's get started. So the goal of this lab was to first create charged pieces of tape. After we created the charged pieces of tape called U-tape in the experiment, we can observe the interactions with the tape and the different interactions with positively and negatively charged objects. Then we calculate the excess charge on the tape, calculate the excess number of electrons on the tape. And why are we doing this? We are doing this experiment so that we can create a visual representation of charged particles. And this will help us better understand the way that charges interact with each other. Here are the results of the experiment interactions. It compares object 1, object 2, and if there was an attraction or if they were repelled against each other. For 2 U-tapes, there is a repulsion. For 1 U-tape in my hand, there was an attraction. For 1 U-tape in the desk, there was a slight attraction. And for 1 U-tape in the pen, there was a strong attraction. The conclusion from this experiment and these results is that since the pen was made negative by me rubbing it against my hair, the U-tapes have a positive charge. Now let's talk about the calculation prep, or the given measurements. The length of tape is 0.2032 meters, the mass of the tape is 0.002048 kilograms, and the distance of the floating tape is 0.003 meters. Therefore, the magnitude of the gravitational force, which is just the mass of the tape times the gravity, is 0.00201 newtons. Therefore, the magnitude of the electric force equals that, which is 0.00201 newtons. Now let's go ahead and calculate the amount of charge that's on the U-tape. So we know the magnitude of the electric force equals 1 over 4 pi E naught times the magnitude of Q squared over the vector of R squared. This Q squared is Q squared instead of Q1 times Q2 because we can assume that both pieces of tape have the same charge and that they are both treated as a point charge. Next, we know that the magnitude of the electric force equals the magnitude of the gravitational force. Therefore, we can set these equations equal to each other to find Q. After doing algebra, we see that Q equals the square root of the magnitude of the gravitational force times 4 pi E naught over 1 times the magnitude of the vector of R squared. This gives us the resultant, which equals 1.42 e to the negative 9c. We know that the charge of an electron equals 1.6 e19c. Therefore, the number of excess electrons on the tape equals the resultant charge divided by the charge of 1 electron. This equals 8.86 e9 electrons. Now let's talk about the calculations on how to find the fraction of atoms that gave up electrons. So, we know from the last slide that the number of excess electrons on tape equals the resultant charge divided by the charge of 1 electron. That gave us 8.86 e to the 9 electrons. So, the number of atoms on the sticky side of tape equals the length of the tape divided by the diameter of an electron, which equals 0.2048 divided by 1 e to the negative 10. This gives us 2.048 e to the 9 atoms. Therefore, the ratio of the number of electrons, excess or deficient, to the number of atoms on the sticky surface is approximately 4 to 1. Here are 2 screenshots. The first screenshot is a screenshot of the GlowScript computation on how I calculated and got the answers for some of the equations that we talked about in previous slides. On the left, this shows a representation of those computations. The blue sphere represents the top tape, and the red sphere represents the bottom tape. We have two arrows, one facing up for the electric force and one facing down for the gravitational force. You can see that both of these arrows are the same in length, and this represents that they both have the same magnitude. And at the bottom, it prints the charge of the tape and the number of electrons that are on the tape. Now to answer some of the required conclusion questions. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged items? This would reverse all of our data. The tape would then repel my hand, repel the normal forces like the book and the table, and it would also repel the pen after I rubbed it against my hair. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? It is important to handle the charged tapes as little as possible because of the strength of their attraction. When the charged tapes came in contact with my hand, they would be attracted to the object less and less every time I tried to test that attraction. Thank you so much for tuning in.